Okay. So next, quality factor. Okay, Q means quality factor. Okay, you know quality factor means by definition Q is equal to F naught divided by bandwidth. Okay, that means when you have some circuit. Okay, say this is your circuit. Okay, this is like a central frequency, and the difference between these two is called as a bandwidth. Okay, the difference between these two is called as bandwidth. Okay, bandwidth can be measured in terms of omega, or it can be measured in terms of f also. Okay, once if we measured with respect to omega, then that is like a radian per second. Okay, then or otherwise that will be like a hertz. Okay, whether they mention or not, if you put omega, sorry, if you put f naught upwards, then this bandwidth also should be like a hertz only. So once here the numerator is hertz, the denominator is like radian per second, this is not allowed. Okay, then that will make some confusion. Okay, so don't get that kind of confusions there, because ultimately q is like a number. Okay, so it's a number, it will not have any one. Okay, so once if the numerator is like hertz, then denominator also has to be hertz only. So you can also put omega on there with this means. So yeah, with means you can put here f2 means f1 like omega 2 means omega. Okay, so you be a little bit careful here, because you should mix. Okay, once if you mix, then your answer will be okay, q is equal to f divided by bandwidth. Okay, q is equal to f naught divided by bandwidth. Okay, q means quality factor, f naught means resonant frequency or center frequency, d means bandwidth the circuit. Okay, already some method how to measure q for any circuit. Okay, okay, see, for a practical inductor you can measure q, practical capacitor you can measure q, or for any RLC circuit you can measure q. Okay, by definition q means 2 energy stored. Okay, this energy stored divided by maximum energy dissipated per cycle, energy stored divided by dissipated energy dissipated per cycle. Okay, so this is a definition. And without fusion can also like, because this fusion cycle in the per cycle is not there. That's why this 2 pi will be, you can write this. So without confusion, q is equal to power. Okay, power stored divided by power dissipated. Also you get dissipated. Say example, for example, if I am having the practical will have, along with the inductor will have some resistance also, some series resistance will have. Okay, when a practical inductor is there, inductor some series resistance. Now you know, for example, current I am telling. Okay, now what is the energy store? What is the okay, power energy? Power means with respect to one energy means with respect to total duration. Okay, in one cycle, what is the energy that it can store? Okay, so energy stored by inductor is the current value I. Okay, I square, and what is the reactance of this inductor? Reactance is like Z, that is like omega. Now what is power that will be dissipated by this resistance? Power is simply I square R, this will reach then omega L divided by R is the quality of the practical factor. Qualified practical. Okay, see, for capacitors also you can find. Okay, for capacitor the quality factor is equal to 1 by omega CR. Okay, 1 by omega CR. Okay, now you know the quality factor for inductor and capacitor. But quality factor of resonance. Okay, we are a resonance. Okay, because if you see here, the quality factor depends on frequency, because you can do your frequency. The frequency will get quality factor. But if you are operating under condition, okay, operated resonant condition, the quality factor here Q is equal to LIR. Okay, or otherwise also calculate like not CR. Both are okay. Okay, so for series resonance, not L by R. Otherwise, 1 by omega not CR. Okay, you can also write some other 1 by R. Sort of by 6. This omega naught. Okay, how this omega naught is 1 by side of 6. Already you calculate what is omega naught. Omega naught is equal to by, I don't know or not. Okay, yes. Yes, we calculated. So omega naught is equal to 1 by square LC that you do. So like also you can, now you can convince yourself, because in the beginning I told you. Say for example, this is the denominator. The square root of LC is in the numerator. Somebody takes ohm to the numerator. Ohm only. Plus square root of L by C only, because we have seen here this square root of LC. I think okay, that is like a only. That means your answer is right. Fusion in the future. Okay, it is like this. It is like this. The fusion. Okay, one square root of LC will come. Scale will come. Confusion you will understand. Okay, so right that you should know that unit concept, yes, unit relation concept. Okay, so that you can remember it any fusion. Okay, this is Q. Now then, what is bandwidth? Okay, bandwidth equal to omega 2 minus omega 1 is equal to R by L. Omega 2 minus omega 1 is equal to R by L. Okay, then how to measure this bandwidth? Okay, is there any other way to measure this bandwidth that is equal to R by L? Say for example, Q is equal to, we have Q is equal to omega naught L by. Now you know what is omega. Okay, and Q is equal to so Q is equal to F by bandwidth. Okay, Q is equal to F omega naught divided by bandwidth. Now I have to find out bandwidth. Okay, omega divided 2. Now what is omega means certain frequency, that is 1 by 2 tells. I also know what is Q. Q means what? Q means omega naught. Okay, omega naught by R. Okay, so yes, sir, somewhere it's gone. Yes, is okay. We are getting answer, correct answer. Somewhere. we get a bandwidth as R by L. Okay.
Sir.
Something is going wrong. Yes, yes. So here, yes, yes. Okay, this is omega naught. Q is equal to omega naught L by R. Okay, omega naught cancels R by L. Okay, so bandwidth in fusion for C circuit is always R by L. You can convince yourself. Okay, so somebody tell me bandwidth I have calculated what in hertz or radian. Bandwidth I have calculated in terms of hertz or radian per second. What is the unit of this bandwidth? Any? What I here? I'm using 80%. Okay, I'm using omega naught. So this is radian per second. Okay, so and meaning it's 5 2. Okay, so radian second is equal to 1 by second. Okay, by tau. Okay, because okay, so we had the relationship like this because omega that this side is like 1 by tau. Okay, this omega side 1 by tau. Okay, is that is one R by L is because what is 1 by tau? 1 by tau means tau is equal to L by R. Okay, so tau is equal to L by R. That doing R L. You okay? Are you getting understand this? Is happening finally? So integer do not put L by okay, R by L only correct because the denominator 1 by tau, tau means L, that is going as R by L. Okay, so integer don't put L by R, that is wrong. Okay, okay, so bandwidth always R by L. Okay, that to radian per second, not in hertz, will be in percent. Okay, so and the next, okay, then what is the voltage? What is the resistance, inductance, and capacitance? Find the voltage admittance. Okay, at any other frequency can be like this, okay, because this is any frequency, you can put any frequency, but at a frequency, what is the voltage across each element, okay, across resistance, inductance, and the capacitance that we have to see. Okay, so at omega naught, okay, so what is the voltage of this resistance? Because R is equal to R in R, but you know, at resonance, the current is maximum. Okay, so that current I will call it I naught. Okay, I naught in R. Also, I naught means supplied voltage by the resistance. Okay, applied was magnitude by the resistance. Then I multiplied with resistance. Then I am getting resistance. Okay, so one thing is say take the circle like this. Okay, now you apply voltage here. You apply some voltage R, L, C. Now what is happening? See, where is the short? Okay, virtually is like a okay. Once it is short will up. Okay, once it's virtually short will up. Resonance is like really this like a short. Then what will happen? B has to be V only. Okay, so that finally getting B is equal to V. Okay, so we mod this value. So V is equal to VR, or V is equal to V. All are same. So finally, okay, V is equal to VR. Then what is the voltage the inductor? It does that. The inductor because both coming together is looking short, but inductor is there, its capacity also. Okay, we have removed that. Okay, so what is the voltage across the what is the voltage across the capacitor? Now we know resonance current flowing that we okay at resonance what is the current flowing? The current is V divided by R because resonance the current is flowing in the circuit. I is V divided by R. Okay, now what is the voltage? Voltage here means the current offered by this inductor. Okay, so the inductor you can write like this, say for inductor B equal to plus JXL. Okay, J means impedance offered by the inductor into the current. Okay, current, maximum current. Okay, so plus J omega naught L plus it is a frequency plus omega naught L and I naught. Now know what J omega naught. What is I naught value? Okay, I naught means V divided by R. Okay, simply if we take the modulus value V divided by R. Okay, you know in this omega naught L divided by I can replace it because omega naught L R is like a Q. Okay, this is like Q mod V. JQ mod V. Okay, so the inductor is like a plus JQ mod V. Second, what is the current? Sorry, what is the voltage across the capacitor? The VC minus JQ into I current. Okay, the I naught value. The I naught. Okay, so minus J omega C I naught value is mod V divided by R. Okay, again minus J mod V. Then what is this omega CR? Okay, 1 by omega naught CR is also equal to Q only. So this is minus J Q mod V. Okay, minus J Q mod V. Okay, so finally, what is the voltage? Now the voltage here is simply VR is equal to simply V. Okay, mod V. Then VL is equal to plus J Q mod V. Then VC is equal to minus J Q mod V. Somehow it is satisfying the KVL because what the KVL is telling at any point of time V is equal to VR plus VL plus VC. Somehow it is satisfying because here if you put VR is equal to V, then VL is equal to plus JQ. This is minus JQ. Okay, anyway that mod V will be there, but both are cancelling. The voltage is there, but they are like opposite nature. That's why these two is cancelling. Finally only V is there, V and V is there. But anyways, what is happening, the voltage across the inductor and the capacitor is like it is getting amplified. So the series resonance circuit can also be called as voltage amplification circuit. Voltage amplification circuit. And again, don't ask, sir, can we use it for amplifier purpose? We cannot use it. Okay, because amplifier means it has to amplify all the frequency, not only the center frequency. So, okay, so it is like a voltage amplification circuit under resonant frequency. Okay, so now, okay, so now then in practical cases, you know what is Q. Okay, then that many times the voltage is getting increased. Okay, similarly here also, but it is in the opposite direction. That's it. Okay, that is the idea. Okay, next we will concentrate on the bandwidth. Okay, so bandwidth. Okay, this is omega frequency. This is current. Okay, this is the maximum current. Okay, I naught, and the power there is P naught. Okay, I naught divided by root 2. At this time, power is like P naught divided by 2. This is corner frequency omega 1. This is center frequency omega naught. This is upper corner frequency, that is omega 2. Okay, so and again this nature, okay, resembles, okay, the band pass filter type. Okay, band pass filter. Okay, that means what? It is not allowing the low frequency, it is not allowing the high frequency, but in between the frequency it is allowing. That's why this is band pass filter, where omega 1 is lower cutoff frequency, omega 2 is resonant frequency, omega 2 is upper cutoff frequency. Okay, upper cutoff frequency, and then omega naught is like a central frequency or resonant frequency, So and again, you know, I is always mod I is equal to V divided by R square omega L minus 1 by omega C whole square overall square root. Okay, now at resonance, what is happening? Okay, so at resonance, okay, it's not at resonance. Okay, see at corner frequency, what is happening at corner frequency? Yes. Okay, so this is like at a corner frequency. At corner frequency, what is happening to mod I, sir? That mod I, okay, see that mod I becomes mod I divided by 2. Okay, I naught divided by 2. Okay, what is happening to the current? Okay, the current becomes like I naught divided by root 2, the maximum current, that becomes like a 1 by root 2 times. Current becomes 1 by root 2. Okay, so so that's why the mod I is equal to exactly corner frequency. This is R square omega L minus omega C whole square. So what happens to this value? That value is like some maximum value is there. Okay, from that maximum value, it becomes like 1 by root 2 times. That means 0.707 times. You know what is that maximum value? Because once if omega L and 1 by omega C is same, that is like V by R. Okay, so that means I naught. Okay, that is I naught. Okay, I naught I can replace by V by R. Okay, and already root 2 is there. Okay, already root 2 is there. Okay, so V divided by root 2 R. Anyway, V is there. Okay, so now I have to relate these two. Okay, so these two I have to relate. Okay, so under this condition, once if you relate these two, okay, so just square on both side R square omega L minus omega C whole square, that is equal to 2R square. Okay, so once if you proceed further, okay, so finally you will get omega L minus omega C is equal to plus R minus R. Okay, plus R minus R. Now at corner frequency, at omega is equal to omega 1, because we are having two corner frequency. One is at omega is equal to omega 1, the another one is at omega is equal to omega 2. Now we have to see when omega is equal to omega n, whether we will get plus R or minus R. Okay, what we will get, plus R or minus R. Okay, so when omega is equal to omega 1, okay, that means what? When the resonant frequency is here, when you are here, your omega 1 is here. When your omega is less, okay, when your omega is less, which one will dominate? This one will dominate. That means negative will dominate. So that time you will get minus. Okay, so when omega is equal to omega 1, Okay, so omega 1 L minus omega 1 C, that is equal to minus R only. Okay, you will not get plus R because the second term will dominate. Okay, so similarly, when omega is equal to omega 2, okay, omega 2 means you are at high frequency. When high frequency is there, first term will dominate. Okay, this term will become low, so you will get the positive R. Okay, so omega 2 L minus omega 2 C is equal to plus R. Now you have two equation, okay, two unknown variable, that is omega 1 and omega 2. Okay, so from this you can measure what is omega 1, you can calculate what is omega 2, because we know what is omega naught, but we do not know what is omega 1 and omega 2. Okay, so from this equation you can calculate what is omega 1 and what is omega 2. Okay, you just try to calculate. Okay, so once again from this we can proceed further in other manner. Q is equal to f naught divided by bandwidth. Anyway, this is already written, or otherwise omega naught divided by bandwidth, whatever it may be. If it is omega naught, this is omega 2 minus omega 1. If this is f naught, this is f2 minus f1, or the bandwidth is equal to omega naught divided by q. Okay, omega naught, and again you know this omega naught divided by q. Finally the bandwidth we have already calculated, that is r by l. Okay, that is r by l. Okay, and finally the bandwidth is r by l is like a radian per second, this you know. So how can we write differently? Because if it is in radian per second, I can also write in f2 minus f1 format. Okay, there instead of l I will put 2 pi l, because the 2 pi comes from here. Okay, this is like that time I can write in terms of heads. Okay, that time I can write in terms of heads first. Then this omega naught, most of the time this omega naught is equal to the geometric mean of the omega 1 and omega 2. Okay, so but it is not necessarily to be true always, but at some time, most of the time, the omega naught is equal to square root of omega 1 and omega 2. Okay, so and also you have and again, say for example, if this is like this, okay, your corner frequency is here, this is omega 1, this is omega 2, this is like half of the bandwidth, this is also like half of the bandwidth. Okay, this I can put like bandwidth divided by 2, this also I can put a bandwidth divided by 2. Okay, then this is omega naught. So omega naught minus omega 1, omega naught minus omega 1 is equal to bandwidth divided by 2. Okay, so and you know what is omega 1? Omega 1 is equal to omega naught uh, omega 1 is equal to omega naught minus, okay, minus bandwidth divided by 2. Okay, so what is this bandwidth actually? The bandwidth means okay, we have seen just now, bandwidth means r by l. Okay, so I can put r by 2l. Anyway, this is frequency, okay, radian per second. Okay, so or otherwise I can also write, okay, so finally omega 1 is equal to omega naught r divided by 2l, or otherwise I can also write like this, f1, this is f naught divided by 4 pi l hertz. Okay, see already you have found out what is f1 by some method. Here also you can find out and make sure that both are correct. Okay, this is like f1. Similarly, you can also measure what is f2. Okay, see that time omega 2 minus omega naught is equal to bandwidth divided by 2. Omega 2 is equal to omega naught r divided by 2l. Okay, then f2 is equal to f naught r divided by 4 pi l, again hertz. Okay, so one thing is finally the resonant frequency f naught, okay, f naught or omega naught, independent of resistance. Okay, independent of resistance, independent of resistance. Okay, now finally again, what is selectivity or quality factor, that we have to see, because quality factor Q is equal to I think we have calculated the quality factor, that is 1 by r square root of L by C. Yes, yes, no need to do that again. Yes, okay, so almost we have completed the series resonance part. Okay, in the next class we'll start the parallel resonance. Okay, so I am ending with this. Okay, if you have any doubt, we can meet on tomorrow and we'll see. Yes, okay, is it okay? Yes.